A mission to study one of the solar system's most promising environments that may be suitable for life has lifted off. NASA's Europa Clipper spacecraft, designed to explore its namesake, Jupiter's moon Europa, launched aboard a SpaceX Falcon Heavy rocket Monday at 12:06 p.m. ET from NASA's Kennedy Space Center in Florida. The long-anticipated liftoff, initially scheduled for October 10, was delayed by Hurricane Milton, but crews on site at the center evaluated launch facilities after the storm and cleared the spacecraft to return to the launch pad. Now, the spacecraft has successfully entered orbit, and NASA confirmed they received a signal from Europa Clipper about an hour and 10 minutes after launch, which means that mission control is communicating with the spacecraft and receiving data. Europa Clipper's large solar arrays, which will help power the spacecraft on its journey, deployed 3 hours after launch. Europa Clipper will serve as NASA's first spacecraft dedicated to studying an ice-covered ocean world in our solar system, and it aims to determine whether the moon could be habitable for life as we know it. "This is the start of our journey of discovery," said Jenny Kampmeyer, a science systems engineer at NASA's Jet Propulsion Laboratory in Pasadena, California, during a live NASA broadcast. "Everything we're going to learn from Europa, it's just amazing. All scientific disciplines can really gain something from this, and it's going to change our understanding of our place in the universe if this is a world that could support life." Clipper will carry 9 instruments and a gravity experiment to investigate the ocean beneath Europa's thick ice shell. The moon's ocean is estimated to contain twice as much liquid water as Earth's oceans. "The instruments work together hand in hand to answer our most pressing questions about Europa," said Robert Pappalardo, the mission's project scientist at JPL, in a statement. "We will learn what makes Europa tick, from its core and rocky interior to its ocean and ice shell to its very thin atmosphere and the surrounding space environment." The spacecraft also carries more than 2.6 million names submitted by people from countries around the world and a poem by U.S. Poet Laureate Ada Lyman. The $5.2 billion mission began as a concept in 2013, but the road to launch hasn't been without challenges. In May, engineers discovered that components of the spacecraft may not be able to withstand Jupiter's harsh radiation environment. However, the team was able to complete necessary testing in time and get approval in September to proceed toward launch, preventing a 13-month delay of the launch with no changes to the mission plan, goals, or trajectory. "There was no harder year than this one to get Europa Clipper over the finish line," said Kurt Niebuhr, Europa Clipper program scientist. "But through all of that, the one thing that we never doubted was that this was going to be worth it," Niebuhr said. "It's a chance for us to explore not a world that might have been habitable billions of years ago, but a world that might be habitable today. A chance to do the first exploration of this new kind of world that we've discovered very recently called an ocean world that is just totally immersed and covered in a liquid water ocean, completely unlike anything we've seen before. That's what's waiting us at Europa." What to expect after launch? After launching, the spacecraft will travel 1.8 billion miles, 2.9 billion kilometers, and is expected to arrive at Jupiter in April 2030. Along the way, the spacecraft will conduct flybys of Mars and then Earth, using the gravity of each planet to help the spacecraft use less fuel and gain speed on its journey to Jupiter. Europa Clipper will work in concert with JUICE, or the Jupiter Icy Moons Explorer, spacecraft, launched in April 2023 by the European Space Agency, which will arrive to study Jupiter and its largest moons in July 2031. The largest spacecraft NASA has ever built for a planetary mission, Clipper is 100 feet, 30.5 meters, across, longer than a basketball court, thanks to its solar arrays. The massive panels will help to soak up enough sunlight to power the spacecraft's instruments and electronics during its investigation of Europa, which is 5 times farther from the Sun than Earth. Once it arrives, the spacecraft will spend its mission conducting 49 flybys of Europa, rather than landing on the Moon's surface. Mission teams initially worried Clippo would not be able to withstand Jupiter's harsh environment because the giant planet's magnetic field, which traps and accelerates charged particles and creates spacecraft-damaging radiation, is 20,000 times stronger than Earth's. But engineers found a way around that problem. Each flyby of Europa, expected every 2 to 3 weeks, will cause the spacecraft to spend less than a day subjected to Jupiter's punishing radiation before it loops back out. The time between flybys can help the spacecraft's transistors, which help control the vehicle's flow of electricity, recover from radiation exposure. Meanwhile, a specially designed vault made of titanium and aluminum will protect the spacecraft's sensitive electronics from radiation. Eventually, the flaggers will bring Clipper within 16 miles, 25 kilometers, above the surface, soaring over a different Europa location each time. This strategy will allow the spacecraft to map nearly the entire Moon. And once the mission is complete, the spacecraft's journey may end its journey by crashing into the surface of Ganymede, Jupiter's largest moon, although that has yet to be determined. The tantalizing potential for life. Europa Clipper isn't designed to search for evidence of life on Europa, but it will use an array of instruments to see whether life could be possible within an ocean on another planet in our solar system. Astronomers believe that the ingredients for life, including water, energy, and the right chemistry, may already exist on Europa. The spacecraft could gather evidence to find out whether those ingredients coexist in a way that makes the Moon's environment potentially habitable. The mission will investigate the exact thickness of the ice shell that encases the Moon and how that frozen exterior interacts with the ocean beneath it, as well as characterize the Moon's geology. Scientists are keen to know the exact composition of the ocean and what causes the plumes that have been previously observed rising up through cracks in the ice, venting particles into space. They also want to determine whether material from Europa's surface trickles down into the ocean. To carry out a thorough investigation, Europa Clipper is outfitted with cameras and spectrometers to capture high-resolution images and create maps of the Moon's surface and thin atmosphere. The spacecraft also carries a thermal instrument to spot locations for plume activity and where the ice is warmer. A magnetometer will study the Moon's magnetic field and confirm the existence of Europa's ocean, as well as its depth and salt content. Ice-penetrating radar will peer beneath the outer shell, estimated to be about 10 to 15 miles, 15 to 25 kilometers, thick, to seek out evidence of the Moon's ocean. And if there are active plumes venting particles into space from Europa's ocean, the spacecraft's mass spectrometer and dust analyzer will be able to sniff the particles and analyze their composition, said H. Korth, Deputy Project Scientist for Europa Clipper at Johns Hopkins University's Applied Physics Laboratory. The mass spectrometer and dust detector data will show whether Europa harbors the composition and chemistry required to host life, Korth said. All the instruments will be turned on and operating during each flyby to gather the most data possible. The Europa Clipper team is often asked about their hopes for what the spacecraft will uncover at Europa, and how it could pave the way for future exploration in the search for life beyond our planet. To me, it would be to find some sort of oasis, if you like, on Europa where there's evidence of liquid water not far below the surface, and evidence of organics on the surface, Pappalardo said. Maybe it would be warm, maybe it would be the source of a plume. That could be somewhere that in the future maybe NASA could send a lander to scoop down below the surface and literally search